In this chapter, we will be looking at rational expressions. In this lesson, we will be focusing on multiplying and dividing rational expressions.
All right, so when it comes to multiplying and dividing rational expressions, it's actually a lot easier than adding and subtracting, okay? And what we're going to do first of all is we're going to factor all the numerators and denominators, okay? And then we're going to identify all the NPVs. Now this is specifically, let's think of it like this. This is specifically if it's multiplication. Okay, these are the things that we're going to do if we're multiplying here. So factor numerators and denominators, we're going to identify all NPVs. Then what we're going to do is we're going to start to cancel factors. And remember, any factor that's shared from the numerator to the denominator, that sort of division just becomes 1. And we're going to reduce everything. Because we multiply straight across, right? So let's say, for example, we had, let's say, 2/3 multiplied by, let's say, 5 quarters. Okay, so what we're going to do here is I notice there's a factor of, so I'm going to write these as in terms of factors. So instead of 4 here, I'll maybe write 2 by 2. Okay, I'm just doing this to give you a kind of a sense of what's going to happen here. And then I know that that 2 over that 2, okay, is going to become 1, right? And now what I'll do is I'll just multiply every other factor that we're left here. So 5 times essentially 1. And then the 3 and the 2 are left over. And so that would become 5, 6. That's basically what we're going to do. Now, if we're talking about division, what we're going to do is we're going to remember multiply by the reciprocal when you're dividing by a fraction. So dividing, what we do is we take dividing and we turn it into a multiplication problem by multiplying by the reciprocal. But there's something you got to remember here. When you've got two fractions, okay, so if you've got, for example, A over B, and we're going to divide that by C over D, okay, my non-permissibles are going to be from here and here, okay? Because either the dividend or the divisor here is going to be, could be undefined. However, when we change this into a multiplication problem by multiplying by the reciprocal, now all of a sudden C is in the denominator as well. So C could possibly produce a non-permissible as well. So in a division statement, our non-permissibles are actually going to come from these 3 places. Okay, in a straight multiplication, it's just the denominators. But with a division, we got to consider all 3 of these different positions here as producing non-permissibles. Anyway, so let's take a look at some examples. All right, so we're just taking these 2 fractions and multiplying them together here. Now let's just take a look at the factors here. We got 5, 3x's, 8, and a y here. Now remember, 8 is like 2 times 2. And we've got that extra y there. And then in the denominator, I've got 2 times y, and then we're going to have 15. Now 15 is 3 times 5, and then 2 x's. And so what's going to happen here is this is going to be, actually I should do it like this. I should write, I've been doing this consistently thus far. Make this equivalent. First of all, okay, one of the 2's is going to cancel, and then one of the 5's is going to cancel. I've got 3 x's in the numerator, 2 in the denominator, so the 2 of them will cancel. I'll still be left with a 1 in the numerator, and then the 2 y's will cancel. And so I'll be left with x times 2, or 2x, over, well, in the denominator all I've got left is a 3. Now, these 2 are equivalent until I state the non-permissibles, which in this case would be that x can't equal 0, and y can't equal 0. And I really do need to state those because my final answer here isn't undefined anywhere. So if they're going to be the same, I would need to include some sort of comment about those. Okay, now that's not the only way to do it, but I think a lot of us, for a lot of you, you're going to find that easier than trying to like multiply, for example, 5 times 8 to get 40, 2 times 15 to get 30, and then kind of reducing it down from there. I just want to make sure that I caught that, because as soon as I said it, I'm going to get 40 over 30. So wait a minute. Oh my gosh, there's another 2 in there. That should have been 4x. Sorry, there's another factor of 2 in 8. I only threw down the 2 there. So 4x over 3. Okay, now, this guy over here, again, the 4 there is going to be 2 times 2, and there's a negative 1 out front. Got the 3b squared, that's 2a, there's 2 of them. So this is going to become, think of it like this, that's going to be 2 times a cubed over 3b, and then we're going to change that division to a multiplication. Now I don't really have to worry about the non-permissibles right now because there's the b, right now the b is in the denominator in both cases right here, and b won't, I'll have to state at some point that b can't be 0, and that'll cover both. But I'll multiply by the reciprocal, and that'll be 3b squared over, now this is 2a squared, so that means 2a times 2a. Now, let's eliminate the ones here. So there's 2 divided by 2, 2 divided by 2, 3 divided by 3. So essentially all of our coefficients disappear. I've got 3 factors of a in the numerator, 2 in the denominator. So we'll be left with just 1 up there. I've got a factor of b in the denominator, 2 in the numerator. So the negative sign survived, and then the a and the b. Now remember, these are only equivalent though until I state the non-permissibles. And in this case, the non-permissibles are going to be b. B can't be equal to 0. And then because of the reciprocal here, I put an a in the denominator, which means now a can also not be equal to 0. And so now we can state that those are equal. Let's come over here. Okay, now we got something where we got to do a little bit of factoring. That's good. So here in the numerator, that would take out the common 3. In the denominator, I've got that common 2. Up here in the numerator, the common 5. And in the denominator here, the common 6. All right, now we're going to find the ones, right? Now remember, 3 and 6, there's a common factor there that's going to leave me with a 2 here. And then the 5 and then the 2's, there's nothing for them to cancel with because the 5 is in the numerator all by itself. These two 2's won't cancel because they're both in the denominator. So instead of canceling becoming a 1, they're going to actually multiply and I'm going to get a 4 down there. Now, x minus 1 over x minus 1 is 1. X plus 1 divided by x plus 1 is 1. And so what I'm left with here, and again this is only equivalent, is 5 over 4. But look at my denominators. I can't allow x to be equal to negative 1 or positive 1. So x can't equal plus or minus 1. As soon as I identify those, they're equal. I don't have to worry about the numerator here because this is all division. I didn't have to do any kind of reciprocal, so that was fine. That stayed the way it is. There was nothing that needed to be addressed there. However, this one is division. So what we're going to do here, first of all, we're going to factor just like we did. I'm going to take out the common 4 here, so m plus 2. And then here in the denominator, 3 times n minus 1. Now, I'm going to keep the division here for right now, okay? Because I'm going to take a look at what I've got here. I factor that out here. I've got 2 times m plus 3. Take out the common 7n minus 1. Now, at this point, it's probably smarter now to start to identify these non-permissibles. So for right now, I can tell you that n can't be equal to 1. Okay? Now, I'm not saying that because I have to here. I mean, I can see it right away there. I'm stating that because things are going to change here in just a second. I want to make sure that I remember that. Now, I'm going to multiply by the reciprocal. I'm going to multiply by 7 times n minus 1. 2 times n plus 3, and I'm going to bear in mind that n can't equal 1. Now, do I need to keep writing this? Well, no, it wasn't necessary to write it in the first place, but I'm using it to help me figure out what's going on here. Now, additionally, as soon as I reciprocated it, now that m plus 3 fell into the denominator, which means now m can't equal negative 3. Whoops. So there's another non-permissible. And now I'm going to start to find my ones. So with 4 and the 2 there, there's a 1. Okay, there's a factor of 2 here, but there's another one here that I didn't get rid of. The coefficients, the 7 has no pairings up, neither does the 3. However, the n minus 1 becomes 1. Now, in my numerator, I'm left with 2 times n plus 2 times 7. Well, that's just 14 n plus 2. In the denominator, all I've got left over for the coefficient is the 3, but I've got this m plus 3 here. Again, these would be equivalent, but I've already stated the non-permissibles. N can't equal 1, m can't equal negative 3. And again, because I know I've said this before in another lesson here, but just so that you remember here, this n not equal to 1, that needs to be there to make this final result equivalent to this expression right here. The m doesn't equal -3. Well, that's not absolutely necessary because I can see that from our problem right here. Okay, that is obvious in my final answer, but this one isn't. So that one definitely needed to be stated. This one's really here just so that you get full marks. All right, let's take a look at this one. Another multiplication. Good. So the first thing we're going to do is factor. Now the factoring is starting to get a little bit more involved here. Just a little bit more involved. Here, there's only the common factor of m squared, and that's going to leave me with m plus 3. This m squared minus 9 is a difference of squares, so it'll be m minus 3, m plus 3. And all of a sudden, right away, I can see that there's going to be some canceling here. Up here, I've got this common m minus 3, ooh, and I can see that those two, because that's in the numerator, this is in the denominator, and then the m squared. Now, at this point here, like we said before, probably should identify our non-permissibles. Now, at this point, it's not absolutely necessary because I can see all the factors in there that are going to contribute this. But this is going to be 3, -3 is no good, and then because m is all by itself here, 0 is no good as well. And now, m squared divided by m squared, there's a 1. m plus 3 over m plus 3 is a 1. m minus 3 over m minus 3 is also a 1. In fact, the only factor that it survived that is the m in the numerator. But that is only equivalent to m until I state m can't equal 3, -3, and 0 together with it. And now I can state that that's what my final answer is equal to. Good. Let's keep going. Another example here. Okay, well, again, I got a factor, and notice this is division, so there's going to be a little bit more to consider here. But I got a factor first, a plus 4, that is about as good as that's going to get. In my denominator, I'll take out the common a, and I'll be left with a minus 4, divided by, I'm not going to flip that yet, okay, I'm not going to find the reciprocal yet, I'm going to do my factoring. And down here I'm going to get 4 minus a, 4 plus a. Ooh, you know, I don't really like the way that sits. I don't like the way that feels. I don't like this idea of having the 4 in the front. So actually what I'm going to do before I even get to that, okay, take a look at that. This isn't pretty. This particular little term here, all on its own, isn't very pretty. It would be so much prettier if the a squared was up front, okay? But the a squared is negative. And I don't want the first term to be negative there. I mean, I don't typically. So I'm going to factor a negative out of that. Okay? So I'm going to take this -1 out of the denominator, and that's going to make that negative, bracket a squared minus 16. I can move that negative up to the numerator, and so my denominator becomes a squared minus 16. Now, I've done nothing other than just move a negative around. But that is so much nicer to look at. And so now this is going to become a plus 4 over a minus 4. Now, this is going to be divided by -1. I'll put that in brackets so that we don't confuse that with subtraction at this point. And this will be a minus 4, a plus 4. That's so much easier to look at here. Now, before I cancel anything, before I do any kind of reciprocating here, I'm going to identify my non-permissibles. Again, this little step right here isn't necessary. It's just very helpful to me. I've got an a by itself, so a can't be 0. A minus 4, so a can't be positive 4. Same thing here. And then here, a can't be -4. Now I'm going to turn my division into multiplication. Okay, by multiplying by the reciprocal, so a minus 4, a plus 4 in the numerator, and that -1 drops into the denominator. All right, now I can start my little canceling here. And remember, this is all with the understanding that a can't be 0, 4, or -4. Okay, a minus 4 divided by a minus 4 is 1. The a plus 4s actually don't cancel because they're both in the numerator. I'm multiplying to get them together. Multiplication doesn't produce the 1, it's the division that's producing that multiple of 1 here. This a cannot cancel with this a or that a, and the reason for that is because remember that division sign, that bar there, implies a set of brackets around that numerator. So before I could do the division, I would have to add the 4, a plus 4, and because I don't know what that is as far as it can go. And so what I'm going to be left with here is an a plus 4 squared over the a that was left over there. And then that -1 basically makes the whole thing negative. So I'll just slap that negative out front. I can put it wherever I want, but it makes more sense to put it either in front or up on the numerator. Now, that's all true, but I got to make a statement here. I have to state that a can't equal 4 and -4. Okay, because those restrictions don't go away just because I canceled some stuff out here. The restrictions stay there so that my final answer is equivalent to the original question. Now, I should also include that a can't equal 0. However, that's obvious from my answer. Okay. Next one. 3n plus 6 over 3n plus 2. Here's another division question, divided by n plus 2 over n squared minus 1. So, okay, first of all, though, our first goal is factoring, so take out a 3. It'll be n plus 2. 3n plus 2. I really can't factor out that 3 there. That is as nice as that is going to get. Divided by n plus 2. All right, well, I can't do much with that. But this is a difference of squares in the denominator, n minus 1, n plus 1. Now, at this point in time, as we've done before, we're going to state the non-permissibles. Okay, so n can't equal, now in this case that's going to be -2/3. Here, from the difference of squares, it'll be plus or minus 1. Okay, now right now that's all very visible, that's apparent to me, but I'm stating it anyway just so that I get my head wrapped around where the issues are. Now, I'm going to convert this, before I can't want to cancel anything out here, I'm going to convert this division into a multiplication. So it'll be n minus 1, n plus 1, all over n plus 2. Now, my non-permissibles from above stay. Okay? If they were not allowed in one step, they're not allowed in the next step. However, there's a new one that shows up here. I can also not have n be -2 because of that reciprocal. Push that n plus 2 into the denominator. Okay, now, these are going to be equivalent to, well, n plus 2 divided by n plus 2 is 1. And actually nothing else cancels here. So I'm left with 3 times. Now, bear in mind, these 3's don't cancel. They can't. And the reason for that is because this bar, once again, implies a set of brackets around the numerator and denominator. Before I could do the division, I'd have to do what's inside the brackets, and that involves multiplying 3 by n and then adding 2. Because I don't know what n is, I can't do that. That is as good as it can get. So now this is going to be 3 times, and notice neither one of the n minus 1 or n plus 1 disappeared. Now I can leave it as n minus 1, n plus 1. I don't know why I did that in the other order here. Or I could multiply that through, by the way, and get that n squared minus 1. I could go back a little bit. It doesn't really matter. It doesn't really matter. It doesn't make a difference here. And then I've got this 3n plus 2 in the denominator. Now, this will be made equal once I include the restrictions here. Now, the restrictions that I absolutely need, I need to state the n plus or minus 1 and can't equal -2. Those are the ones I need to make this equivalent to the question above it. But to get that full mark here, I also need to include the non-permissible that I can see right here at the end of the question. Okay? Now we've got just a few more examples here to do before we're done. Next page here. All right. Okay, well this is kind of a nice one here. Now, there's nothing to factor here. Everything is as simple as it's going to get here. Notice that our non-permissibles are that x can't equal -2, x can't equal +3. Now, x plus 2 divided by x plus 2 is 1. Now, this is equivalent to x over x minus 3. They become equal, and I hope you're getting sick of me doing it like that. This becomes equal when I state that x can't equal -2. That one is necessary to make them the same. The +3 I throw in there just so that I get full marks for this question. So I've identified all the non-permissibles. Okay, here's another division question. So you know we're going to be reciprocating. But first of all, let's do any factoring that we can do. In the dividend here, there's really not much to be done. There's no common factoring, and these aren't quadratic, so that's about as good as it's going to get. Here, really the only thing that I can do here is take out a 2 multiplied by x plus 3, but I do see the doubling up of the x plus 3. I'm hoping that something's going to happen there, and I got the 4x. Now again, we'll state the non-permissibles. So in this case, x can't equal, well, coming from this denominator, 1/5. And then coming from this denominator, just 0. And again, it's not that I need to state those to make this true. This is just helping me out at this point right here. Now, I cannot do any kind of canceling until I've converted division into multiplication, and I need to multiply by the reciprocal. So it'll be 4x over 2 times x plus 3. Now I can start to cancel stuff out here. Now, the 4, a factor of 2 is going to cancel with that 2 there. It'll leave you with another 2 there. And then the x plus 3 divided by x plus 3 is going to be 1. Now, I should have noted at this point here that we've got a new non-permissible here. X can't equal negative 3 because now I've got a new factor in the denominator. Just got to remember that. And when I kind of divide those all out here, I'm left with a 2 and an x in the numerator. And I'm left with a 5x minus 1 in the denominator. Now these are equivalent to each other. This is equivalent to the original statement of the question until I go through and say that x can't equal. Now I don't really need to say that the positive 1/5 here. I do, however, need to say 0 and negative 3 because those two are not apparent from the final answer. And I'll include the 1/5 just to please the people who are going to be marking my work. All right, next. Again, I hope you're starting to get really comfortable with the pattern. The very first thing I'm going to do is factor. So up here, take out the common x plus 3. Down here, that's a difference of squares, so x minus 2, x plus 2, divided by, I'm not going to do that division yet, and there's nothing to factor there. Now at this point, I will state the non-permissibles that I have at this point here. I've got positive 2, negative 2, and then another negative 2 coming from here. So it's really just plus or minus 2. I haven't done anything yet, right? All I've done is factored, so I can still use the equal sign. Now, I would like to start to cancel stuff out, but I really can't do that until I've got this as a multiplication statement, not a division statement. So I got to multiply by the reciprocal. Okay, so I've multiplied by reciprocal. Now I'm going to be able to cancel stuff, but again, I should be stating that non-permissible as I go down here. And now I'm looking for the ones. So x plus 3 divided by x plus 3. Oh, I'm sorry, and I should have stated that one more. Yeah, I just keep getting ahead of myself. There's one more non-permissible now because I've introduced a new term in the denominator. Sorry, x can now not equal negative 3 as well. Now, x plus 3 over x plus 3 is going to become a 1. X plus 2 divided by x plus 2 will also become a 1. In the numerator, I'm left with just the factor of x, and in the denominator, just x minus 2. Those are equivalent, or that's equivalent to the initial question. It doesn't become equal until I state x can't equal. Now, in this particular case, I need to state 2 and negative 3. Sorry, negative 2 and negative 3, because those are the two denominators, the factors in the denominator that I got rid of, so that's not obvious. And then I would also state positive 2, even though I can see it right there, simply to get the mark. All right, one more division question. We're really ending this heavy in division here. A bit more factoring in this case here. So 4x squared minus 1, that's a difference of squares, so 2x minus 1, 2x plus 1 over x plus 2. Not much to do in the denominator, which is okay. Divided by, all right, what do we got here? Well, we got a common 2x, and so that'll give us 2x plus 1. And then here, okay, I can take an 8 out of that now, but I can see right now, as soon as I take an 8 out of that, I'm going to be left with x squared minus 16, and that's another difference of squares. So x, oh sorry, my mistake, not 16. Whoa, that's crazy bad math. X minus 4. Wow, okay. X minus 2, x plus 2 when I factor that down. Now the non-permissibles as we see them right here, and I'm just stating this to help me out later, would be negative 2, positive 2. And then I got another negative 2 there. So that's all I needed to state here. Now, I will start canceling in just a second as soon as I have turned this into a multiplication statement. So that'll be 8 times x minus 2, x plus 2, all over 2x plus 1. I bring my non-permissibles down, so x can't equal -2, +2. But now that I've introduced new factors into the denominator, I've got a couple others here. 0 for that x by itself, and -1/2 for this factor right here. Okay, now I'm running out of room here, but that's okay, because in the next step here, I'm going to cancel stuff out here. So my initial question will be equivalent to what expression? Well, here, the 2x plus 1's become 1. X plus 2 divided by x plus 2 is 1. 8 divided by 2 leaves me with a 4 up top here. And so now the factors that survive in the numerator were the 4, the 2x minus 1, and the x minus 2. And in the denominator, actually, was just that x right there. And so now these are equivalent until I state the non-permissibles, which in this case will be plus and minus 2 and -1/2. Now, again, to make this equivalent to the original statement, that's all I really need to state, because those are the restrictions that are no longer apparent. Okay, I've gotten rid of them, but they are part of this problem. Now, I should also state the 0, even though that's obvious in the final answer here, I can still see that one right there. Again, I'm just saying that so I can get the full marks for that. Okay,
That's how we do division and multiplication.